Hello, I'm Frank Lamb, and this is a Mastering the Machine video for the Automation Academy for August 5th, 2021. My guest today was Phil Scruggs, and we discussed non-traditional methods of using data acquisition and control in industrial automation. Hope you enjoy it. This is the Automation Academy Mastering the Machine webinar for the 5th of August, 2021. And I'm doing this on a Thursday today because I have to leave from Miami tomorrow and drive the long drive home so that I can get home on Saturday to do personal things. And my guest today is Phil Scruggs, who does a bunch of work up in Oak Ridge and the University of Tennessee. And we got to hang out a little bit last week. I picked Phil up in near Atlanta, south of Atlanta, and we drove all the way down to Miami, stopping on the way and staying in a hotel, and then even taking a little walk, I think in Venice, but then stopping in the swamp, which was kind of neat. We stopped in the Everglades and we just wandered down a road and saw some snakes and bugs and other things like that. So that was kind of cool. And then,
absolutely.
Yeah. Then we came to the plant, and I showed Phil around some of the different things that we do here. There's some pictures and things like that of different parts of the plant that I will show a little bit later. And we got to talking about a lot of different things, but including, of course, what Phil does, which is a lot more high-tech monitoring, much more high-speed monitoring than we do here. But I've been working on this project, gathering data for this plant for a long time in ignition. And so we kind of started bouncing ideas around, and that's where the idea for this webinar came up. I'll explain a little bit what the webinar is about, why Mastering the Machine. It is named after a document that people download sometimes, and I get their email address, kind of a slimy thing, and then I can send them letters and emails and things back. And I don't do a lot with it, but I do promote my Automation Academy, which is a membership site. And some of the people on that site actually steered me from doing just PLC programming videos into talking about other things like career guidance and library, and mostly systems integration and machine building, which is where my background is. So that is the solution to this, which is a series called Mastering the Machine, which is these webinars. And I do also have an initial video on kind of the beginning of quoting machines. But in any case, Phil is here already, so you can see his picture hopefully up in here. And today's topic is non-traditional methods in data acquisition and control, which of course Phil spends most of his life doing all this data acquisition stuff. Probably less so on the control side. I guess you don't make things move, Phil, much?
No, I'm not. I'm not in charge of a machine building process. It's more on the pure data acquisition and condition-based monitoring. So we're trying to install non-invasive sensors on different things and collect the data that way.
So I did see a big motor, and you were gathering a bunch of data from that, vibration data and things like that. And we talked, and Phil's method of analyzing those, I guess they use fast Fourier transforms and things like that to analyze waveforms at a much, much higher rate than PLCs can do. So for instance, I saw today when I was doing a little research from this, I saw a little box that you can hook up to your motor and transmit directly to a PLC that is an analog value. And of course, with what we talked about last week, the only thing you're going to get from that is pretty much amplitude. You're going to know, okay, I have more vibration or I have less vibration. But some of the things Phil showed me is that when you analyze those waveforms, you can find out, is it the bearing that's going to fail, or is it the windings that are going to fail? So why don't you tell us a little bit about what you do there?
Sure. Well, for the past several decades, a lot of different institutions, including the military, have kind of been interested in predicting failures and diagnosing why those bearings are failing. So, you know, big ships, big submarines and things, they go around and they want to have advance notice for when various machinery is going to break. And so for the past several decades, there's been a whole field of vibration analysis, and they have a variety of different algorithms and methodologies for establishing how a bearing is failing, why that bearing is failing, and predicting how long it's going to last in its failed state. That way they can kind of do some preemptive planning in regards to that. And so it's not a brand new field, I guess, in the grand scheme of things, but what's been really interesting is lately, a lot of the sensors have become a lot cheaper. There's many companies that are starting to jump on board. Previously, there were only a few contractors who kind of did it. But today, with just an internet search, there's a lot of hype. There's a lot of startups that are doing a good job, and there's a lot who aren't really doing much of anything, but they're on the marketing train and trying to make it work.
So that's where, when we talked, you mentioned that everything was so high frequency, and of course, those devices are going to do their analysis over there somewhere. And then if you needed to do something with a PLC, they would possibly report to the PLC that, hey, you know, you're nearing a failure point or something. But as far as the actual data, it's so many data points that it wouldn't be particularly useful to bring that into the PLC end of things. It would be much more, I suppose, on the computer end. And then you would report that, hey, you have an imminent failure on your bearing or something.
Correct. I think it's important to kind of emphasize when people say like a sensor, a lot of times in the PLC world, the sensor is just a basic sensor. It's an analog sensor. It's feeding in a voltage or a value, and that's it. It goes straight to the PLC, and that's all that's happening. It's getting a real signal. But kind of in the consumer electronics world, and you'll hear a lot of people kind of discussing the Internet of Things and all the buzzwords that go along with that. They'll use the term sensor interchangeably with sensor plus processing plus, a radio to transmit it somewhere. And that's a much more complex system all on one little chip or piece of equipment.
So that's a good time to lead into our discussion here. This system shown here, what I'm doing right now is I'm bringing points into remote PLC IO to count things. And it sounds like a very simple thing, but Phil, you were here over 7 days ago, and I am still not counting things on the line. I am attached to the feeder that feeds all the boxes into the line, which is a good thing, and that's what I've been doing my work. But the thing that has stopped me from doing this is a series of events. We had a couple of, for those who are familiar with them, Allen Bradley point IO modules, and we installed 2 of those on the line. And then I went in last week and I said, well, I'm going to add these to the PLCs. Well, lo and behold, I looked at the firmware of it, and it was a version C. And I tried to add it into the system, and the PLCs only allowed versions A and B. So I did something called disable keying, and I actually talked to Vlad Romanoff, who's I don't think on here, but got some advice from him. He said, sure, here's the EDS file. I found a copy of it somewhere. He sent me an add-on profile. I tried to add it in that way, and it still didn't work. So then I independently hooked it up to another laptop that I have on the other side of the room, and I actually made it a much later PLC just to test it. And sure as heck, I had a version 30 PLC, and I was still not able to add it on a different laptop. So currently, while disabling this firmware issue, I just basically said ignore the firmware version and try to log anyway, and it didn't work. So version C does not work if you ignore the firmware version. And so the next thing we did was we just went ahead and ordered an older version. So we have those coming in, and then we have to wire the sensors up and things like that. But the basic idea is that I needed to get individual counts of some of these devices out on the line. And Phil and I got to discussing, wouldn't it be nice if we had some temporary way to just hang things out on the line and count objects going by on a temporary basis, right? Because this is something I've been working on for, I don't know, 6 or 8 months, and we still haven't gotten everything wired in permanently. It would be nice to be able to get those counts. And as you can see here with the point IO and everything, yeah, there's a lot of physical wiring and cables and power and everything. And then there's things like this firmware issue. So that's where we got to discussing all kinds of wild ideas. Could this be done with the equivalent of home automation systems or something like that? I did a little research while Phil was here, and I actually added the picture. And there are wireless sensors. What was very interesting is I looked at the technical specs for these, and I did not find out what language any of these speak. They said you do need a gateway of some kind, right? So it's a wireless gateway. But if this is Ethernet and you have to add another Ethernet, say something like an Ethernet IP gateway, what is that? What does that look like? And is it made by the companies that send these? So the research I did do on these things are anywhere from $300 to $600. They're generally battery powered, and you can just hang them on the side of the line, but you still have this other gateway that is kind of undefined. So is that something like a wireless into a point IO module or something? Because as we've talked about here before, the languages that are spoke by PLCs and data acquisition systems are pretty specific, right? So Allen Bradley's Ethernet IP, there's things like Modbus that almost everybody uses, but it does need to be pretty fast, right? Because I'm counting things anywhere from 3 or 4 per second, things coming down the line. I need to be able to pick up transitions that fast. So that's kind of where we got into these discussions, and we got into discussions of things like, can you use a Raspberry Pi? And we even kind of concepted something. Phil, you could maybe talk more about this if you've thought more about it, about taking a device and putting it between the actual photo eye, which would look something like this, but it would have a cable hanging out of it. So disconnect the cable from a cabled photo eye and put a box in between it that would pick up the transition from the photo eye somehow and then transmit it to a Raspberry Pi, something.
Sure, Frank. I can go ahead. Right now, it's screen share is disabled. I've got a few documents that would be great to share.
Yeah, I'll flip that off. That's cool. So I'm going to do that.
All right, great.
Us too, and I do know I have to allow you to do this. So let me see how this works.
Okay.
Don't want to share.
Yeah, you brought together some really interesting kind of ideas about how do these devices communicate, what is industry using, both on the consumer electronic side and then also kind of on an industrial side. What are people using? What's in plants? A lot of people don't really discuss it, and so that's why I'm going to share a little bit of information kind of about what people are using. So let's see if was that able to bring up a screen share?
Yep, I see it.
Great. All right, so this is just kind of a little document. One of the interesting things is it's kind of like trying to hit a moving target. Every single month, a new technology comes out, a new standard comes out. Sometimes the names change. So recently, Zigbee is not used anymore. It's now called the Connectivity Standards Alliance. There's just all sorts of crazy name changes, and trying to keep up is a running battle. But some of the more popular ways that these sensors are talking to a gateway, some of it's of concern to us developers, but some of it's also not of concern, especially on kind of more of the consumer side. So if you're trying to install these in a plant, you might not be interested in the protocol that it's using to talk back and forth to the gateway. You're going to be really interested in what that gateway communicates with. How do we get that back to a database or something that we can access? So some of the more common ones, of course, are Wi-Fi. Bluetooth is a popular one. they're starting to use that in a lot of industrial areas. There's some interesting ones like Bluetooth mesh. I haven't checked on that one recently. Zigbee has turned into Connectivity Standards Alliance, and now it's also that's created something called, let me double check, I think it's called Matter. It's turning into this this thing called Matter. It's a foundation for connected things. And what's really important to kind of know about this one is Google, Apple, and Amazon are all kind of signing on to this method or this protocol. And so it's something that we're probably going to see a lot more often in some of these consumer gateways and sensors. And, you know, there's things like ISA 100, different standards that the developers of the devices kind of have to look into to make sure that their devices are going to communicate with existing industrial systems. And so, yeah, there's just a whole variety of different standards, but they're all kind of accomplishing a similar thing, trying to talk from sensors to a gateway or skip the gateway. You know, you can go with Wi-Fi and go straight to your router or, you know, a gateway that way and kind of skip the middle gateway. But there's just so many options as far as developing your own. So that kind of leads into the next one. Well, why don't you just consider some of the pre-made ones? There's a lot of really exciting options out there. Lots of consumer grade products that are kind of out there and depending on the problem we're trying to solve. So I guess it kind of depends on, you know, the answer is always it depends, of course, but what really matters is what are we trying to accomplish? With a lot of the Internet of Things devices, you can get as complicated as you want. Some of the end goals, of course, are things like predictive maintenance or tracking counts over time or machine learning on the data streams. You can actually put TensorFlow Lite. This is kind of a piece of software on edge devices like Raspberry Pis or microcontrollers, all sorts of different things on the edge. That's cool. You could do classification, you can do sorting, all sorts of really interesting things. Now, these are kind of like the cream of the crop, you know, the latest and the greatest. Things like OpenCV AI kits. These are computer vision edge-enabled cameras that you can get for $200, whereas, you know, 5 or 6 years ago, you were spending $2,000. And so the cost of these devices is just really, really dropping fast. It's really incredible to kind of see what all you can do. You can do things like recognition tasks, face detection, face recognition, part counts, quality, all sorts of really amazing things that you can do with devices that are $200, you know, and these are finished products, they're really ready almost to go. Of course, you're going to have to code them. You're going to have to, you know, do some software, but, you know, these are really nice products. If these products don't even exist, let's say you're trying to do an application that doesn't, well, you can actually 3D print enclosures for your own custom devices. Things like Thingiverse, this is a really popular repository for 3D printed enclosures. So one thing that I've noticed a lot of integrators using have been these DIN rail mounts. Right? Yeah. I kind of came into this from a different engineering background and learned about DIN rails and how popular they are in cabinets and things. And I said, well, how can I mount, you know, a single board computer onto a DIN rail? Well, if you go to Thingiverse, there's a variety of options. Here, you can start to stick things that probably shouldn't be in an industrial environment in an industrial environment. You can kind of push the edge. There's no reason that this Arduino couldn't be made with higher quality components. It's open source. The schematics are available. If you want this thing to operate in temperature range that's outside of room temperature, you know, the major selling point of PLC systems right? They're like industrial hardened. You hear stories about an Allen Bradley system being covered in sawdust for 50 years and still working. Those are the things that people really like. Well, you can design your own system that could be covered in sludge and oil or something, using components and, to do it yourself. And there's a lot of options available now for doing that, whereas previously you couldn't. So all sorts of stuff like that.
One of the things that I'm often concerned with industrial devices, we have what's called determinism, right? So when you're doing publish, subscribe type things, you can guarantee that the communications is happening at some rate. And if it doesn't happen at that rate, it creates a major fault. So often, if I have devices out in the plant, I set them to 20 milliseconds. And that means I need a signal every 20 milliseconds, or I'm gonna shut down. Something's disconnected, right? The communications methods here don't seem to speak of that. And if they're in real time, what does real time mean as far as wireless traffic?
Well, I guess that's probably starting to get into some of the protocols and things that I'm not super well versed in. There's IEEE standards that kind of involve how these devices are communicating. So there are standards that kind of establish how these devices are communicating. And so I guess that's as deep of an answer as I can give is, trust the standard, I guess.
Right. So one of the things I'd thought about, of course, if you had a device at the sensor, then that device can count, right? And it won't miss a count because it's running really fast, local. And if it gets connected, you simply reattach to it later and you pick up the count where you left off, right? But if you don't have that and you simply put a device in there and it's supposed to transmit all of the on and off transitions, and you have a whole bunch of these things all over the plant, then something inside of the gateway, right, needs to be doing the counting and making sure that you didn't lose counts, you didn't lose contact with your device and possibly lose counts. I don't know whether every pulse, right, needs to be transmitted over the airwaves, or if that's indeed how they do it. I would have to think with a banner photo eye that it would have to, right? With those photo eyes that I showed before, there's not much of an option because there's no brain in the banner, right?
Okay, so yeah, if we're going to kind of zoom, all right, so that I guess I was kind of speaking a little bit more broadly about the kind of environment and the space, all sorts of the exciting products that have come out. If we start to kind of zoom in on some of the consumer products and what they're doing, they're basically reporting back to the base what you want them to report back to. So here's some simple Z-Wave door sensors, door or window sensors. They're the magnetic style that you would find on any alarm system, right? There's just a status. The processing that says, hey, this connection is open or closed is happening on this device itself. It's not back on some server somewhere saying this signal is open, this signal is closed. That's just on the device itself. So if you were counting, you would want to do all the counting on the edge device. You would want the total count reported back, once a day or once an hour. You wouldn't want each individual count to be reported back. You would store that on the device and then report it every so often. That way, if you miss a pulse or something because of a forklift driving in front of, the radio, maybe it's a line of sight communicator and the line of sight is broken for some reason. A forklift drove by. You're not dependent upon your count being transmitted every millisecond.
Right. So I guess going back to the ones in use right now, like in industrial wireless photo eye, I don't think it keeps account on the photo eye, as far as I know. It's just a photo eye with a wireless capability, and it transmits to a gateway that may be monitoring somehow that it's getting a heartbeat every X number of milliseconds. That part I don't know. I was unable to find that in their documentation. And when they
Sure.
spoke of a gateway, I don't know if it was a banner gateway or a generic like an Ethernet IP gateway, which handles that for you, right? It does that scan, class, and determinism for you. But what I haven't seen here, of course, you can't close a door, 100 times a second. so you'd never probably care there. You just want to know if it's open, and hey, if it's within a second or two, typical operator interface stuff. You just want to see that it's open.
Okay, yes, absolutely. So if you think about kind of the different applications and things that these sensors have been used for kind of commercially and successfully in the past, a lot of people are familiar with these Amazon Dash buttons. If you ran out of laundry detergent, you could push this button and it would automatically submit an order for laundry detergent and it would show up the next day. That's something that really takes a lot of steps out of ordering laundry detergent for an individual. Now, most people don't really need a button for laundry detergent, right? They've got different ways of getting laundry detergent that they've used in the past, like going to the store or, ordering it, with the mouse. But think about all the other applications you can use this for. Well, apparently Amazon got enough support for these that they now have this AWS IoT button. And this is the same, very similar button that they used in the past. Maybe they got some of these big consumer giants to pay for the development. I'm not sure. But these products are now able to be used by pretty much anyone. They're cheap. I think the cost is $30 for each one of these. And this is simple button presses. Counting's obviously more complicated than simple button presses. And that's where you start to kind of see the gap between the hype and the reality. So button presses, things like digital humidity temperature sensors. There's these Grove sensors that are really popular. They're kind of plug and play sensors for IoT boards. You'll see these a lot. DHT11 sensors. These are kind of temperature humidity sensors. All of the kind of intro 101 projects will have these temperature sensors. Temperature doesn't change that fast, right? You're not trying to count 10,000 readings per second of temperature. But if you're trying to get a count on a assembly line, you might be having products go by at, a product per second, one, or faster, even much faster for certain lines. But there's that's where kind of this discrepancy kind of lies between, fast counting, and then kind of the slow once a minute, once an hour type readings.
Right. So I've got my application is very similar to this right now. I have a machine that is constantly counting, and I don't have the ability to go in and grab individual sensors. So what I'm doing is creating an eternal counter, and it just counts up and it counts up. And I can pick up a count at a certain point and then pick up another count at a certain point and say this many counts happened in this period of time, which it seems like that would be the way kind of to go on this, right? But that means that the sensor itself has to have a little more inside of it. Of course, stuff's cheap now. Arduino, I don't know what the cost of an Arduino is, but that would certainly count. And, you could attach to it and pick up its current count pretty easily.
Exactly. So, there's a variety of different ways to kind of think about it. When I was kind of thinking about it, there's three different approaches that I kind of came up with, and it would have been great to illustrate these. But number one would be to kind of piggyback on the existing sensor. Photo eyes require power. They're not going to be a low power device. They're going to require a pretty chunky battery or an outlet to plug into to power these devices. And so a lot of these lines already have existing photo eyes on them that are powered by a power supply back in a box somewhere. And so if there's a way that you could piggyback on the line coming in, you could get a counter. The next question is, are you at the place you're at, you have, I don't want to say free reign, but you have a lot of opportunities to connect to network infrastructure. Not all facilities are like that. You know, some things are locked down much tighter, and you can't necessarily connect to the Wi-Fi network with your own sensor or Wi-Fi device. You might not even be able to plug into the Ethernet or connect to the network infrastructure in that facility without months of regulatory approval. Yep. Right. And so option number two is, or important thing to consider number two is, can you actually get the data from the device back home to wherever you're trying to get this information? So one of the popular ways of doing that is to use cellular-based devices. One of the more popular ones you'll hear a lot of people talking about is called particle board. Particle board took kind of a open source device in the past. Now they've got much more sophisticated things, but they took basically an Arduino board, added some Wi-Fi chips and a nice user interface, and packaged it together, and now they sell these devices. A lot of people are using these for data acquisition in remote areas. They added a cellular modem. They recently enabled up to 100 devices free cell plan essentially with these. It connects to the cellular infrastructure. As a developer, you don't even have to pay attention to that anymore. I have an example in the past of, this is just, an Arduino board, the standard Arduino board. And you can get these things called hats. They call them hats or add-on boards that go on top of it. And one of the more popular ones is a cellular modem that goes on top of the Arduino board. So you can collect your count data, anything you want. And instead of storing it on an SD card where you have to physically go and do it, you can go to one of these remote areas and have it connect to a cellular tower in the background and update your database with the counts once a day. In the past, you had to order a board. Now you can just pick up a particle boron for $59. It comes with their magic ether SIM, but basically it's a SIM card that connects to the network. Instead of having a $10 monthly fee, they say, hey, you can have up to 100 devices. I'm not sure what the limit on megabytes per month you're allowed to send, but if you're just sending a count, it's not much. And so I wanted to bring this up as a really interesting option, because a lot of plants and facilities, you could get approval to stick your device. They say, yeah, sure, you can put a box on the line that counts, but you can't connect it to our network.
Right.
You can put a box on our line, but you can't get on Wi-Fi. You can put a box on the line, but you can't put any cords across this workspace because of a safety violation, right? You wouldn't want someone to trip on an extension cord powering your photo eye. And so there come a lot of interesting problems that you wouldn't encounter in a home environment that exist in an industrial environment. So you had mentioned, hey, all I want is a count on these lines. I just want to count. It doesn't have to last very long. It's more of a proof of concept. If it's a proof of concept, you can do a battery operated device, and eventually that battery is going to die. If it's a battery operated device, a lot of times people don't like to put those into a permanent installation because that's going to require more maintenance on top of something that didn't have maintenance to begin with. And so, but from a proof of concept point of view, if you're a consultant, you're going in and you're trying to do OEE calculations. What does that mean? OEE is availability, performance times quality. In order to get the performance, you need the production rate. How many parts per minute? How many parts per an hour? And if you can't count how many parts per hour, you're out of luck on that calculation. And so OEE can be valuable. OEE can be long-term, like what's the OEE for the whole year? And in that case, you'd probably want a permanent installation. But a lot of people aren't collecting that metric to begin with. And if you're not collecting that metric, get OEE for a day, OEE for a week, OEE for a month. Those are all well within being able to use a battery powered sensor on a machine 24/7 for several days to get that OEE calculation.
So are these devices something that you can also call and grab the data from? Is that something that can be instigated from the server side, or the client side or whatever, and go?
Oh, absolutely. So the devices I'm kind of showing today, like this particle boron, for instance, these microcontrollers can be updated from the cloud. So if this is deployed in the field anywhere it has cell signal, let's say you've got a different calculation you're trying to report back. Instead of doing OEE on the edge, we're just going to do, a part count. And, we don't want all the complicated stuff. We just want part count, or we want something else reported. You can go into their, their development environment. It's a cloud-based development environment, and you can make your change and you push flash and it goes to the device. It goes to the device, it reflashes in the field. We don't have to configure that. We don't have to program it to do that. That thankfully someone else has done that for us. All we do is push flash and then it updates it. And then if you coded it right, it should spit out the numbers that you want.
So if you had, 100 of these devices scattered around in different places, does each one of them have to have its own effectively phone number?
That's the next question. That brings in a whole nother topic is, all right, if we're trying to do counts on the line and we want 100 of these devices, is it cost effective to spend $60 for each counter? That's starting to add up now. We don't want to spend thousands of dollars for part counters. At that point, it's easier just to have an engineer go into the PLC and extract that value, rather than just sticking part counters on the line.
But again, if you had one gateway, and
if you have one gateway
attached to that gateway, yeah,
correct. So you could potentially have a device like this inside of a gateway, and then much cheaper, lower cost acquisition devices on the line itself. So a cellular modem, it's one of those ways. Let me get this pulled up really quick. Cellular modem, that's one of the ways to wirelessly communicate data. But the thing about 3G, 4G, and 5G modems is they're not cheap. They're not as cheap as a 900 megahertz radio. You have a background in electrical engineering, took coursework in different radio frequencies. I haven't taken that much coursework in those, but 900 megahertz is a popular one. The radios are very cheap, but you can see them online for several dollars. You can attach them to really, really cheap microcontrollers. And I guess these are also called systems on a chip. Yeah. There's a lot of different terminology around these, but ESP8266, this is one of the popular Wi-Fi microcontrollers. You've got a list on Wikipedia for different ones. You say, oh, okay, there's TI devices, there's Espressif devices, there's all sorts of different devices on here. These tend to be really popular. There's a lot of projects on the internet of people working with those. And if you go and take a look at the price, here's a development board. You can plug this into your computer with a USB cable. You can program it. You can connect to Wi-Fi networks, all sorts of stuff like that. It's only $3. I mean, that's almost a throwaway sensor price. And so they're stupid cheap. And you can do a lot of really interesting things with them. If you don't want to use Wi-Fi, you could use a different radio on some of these attached to a microcontroller. So there's a lot of different options out there. You don't have to spend $60 plus a photo eye cost for each sensor. You could do a photo eye plus something else, plus a small microcontroller and a 900 megahertz radio back to a gateway. But that's really kind of on the development. Like if you're doing it custom for yourself kind of product, there's a lot of consumer grade products that exist already to make this easier. So a lot of products, everyone's familiar with Eaton. Eaton has a smart Wi-Fi switch. It comes Z-Wave Plus. It's already ready to go. It's fits a standard. It's cheap. It's just a Z-Wave light switch, and it goes back to a consumer grade hub. This is a fairly generic Z-Wave hub. This one came with an alarm system, and as long as it's got a little sticker on it that says Z-Wave Plus or Z-Wave, you're good to go. You can put Z-Wave hardware on all sorts of different microcontrollers and devices and make that kind of happen. So,
yeah. And in the case of the little device that you were showing us before, that's like $3, of course, you've still got to power it. You've still got to put it in some kind of a hardened case, especially if it's out, and then connect it maybe like we were talking about between the photo eye and the cable. And that way you get your power from that. That's one of the pluses. And you get your little switching from that. Then it can do the counting and everything else. But I have a feeling, it's an economy of scale thing. That's maybe the reason nobody's created industrial versions of these things yet. Is one, there's just maybe not enough demand yet. And then there's, if you had to 3D print every case separately, or go off and get, 100 of them made or whatever, and then bolt them all together and wire them together, make them industrial enough that if you drop it on the floor, it doesn't break. That adds cost, of course, to it, but maybe we're talking about something that's $100 per device instead of $600 per device, and it stores the counts on it so that you can pick those counts up with the gateway or whatever. So,
sure.
Yeah. So one of the nice things about where I'm at down here is I can possibly get funding for little things like that. Of course, the owner of this plant is out on a road trip, as we discussed last week, but he's interested in some of that kind of thing. And it's real easy for him to turn around and say, yeah, we need 10-point IO modules. Well, by the time you've done that, you've spent several $1,000s anyway. And if there's something we could come up with that solves some of those problems, that's portable. I think the portable is it's another thing worth looking at. The battery powered versus putting it in between an existing photo eye. But I am surprised that nobody's come up with less expensive methods of counting things remotely, right? You showed one that was in a park, and I think counting animals is a pretty common thing to do, and putting those little remote cameras on to take pictures of the animals and trigger when the animal runs by so that you can get a picture of Bigfoot or whatever. There's all kinds of applications out there for it. Yeah.
Yep. So yeah, this one's a counter. It just counts how many people walk past a line of sight sensor in a park. Yep. Now, this one's not as fast as an assembly line. It's not as high power. It's not going to count. If 10,000 people walk by this sensor within a time period of 30 minutes, it may not catch them all. We have to look into it a little bit closer, but a lot of these are starting to become products, real products that people have put together and are tracking data on the edge. This is attached to a little box in the middle of a state park. This is remote. There's not much infrastructure here, and they're successfully collecting data. and have been for several years. And it's really exciting to kind of see these applications.
So what is the electron? It mentions these counters are built with the electron. Is that a?
So the electron is their older Wi-Fi. I think it's their Wi-Fi. No, this one is their cellular connectivity. That's the old boron.
Okay.
It's this, but you had to purchase, you had to get your own SIM card and put it in and purchase a plan. Whereas their latest one is all included. But
And then
I'm sure
somebody has to put together a database and the whole bit. All that's a completely different thing, but
yep, but that's become increasingly easy. The other exciting things about this, a lot of these products is you say, okay, well, what about other real world devices? This is a 3D printed centrifuge for separating blood, between the different components. This is just a device. And these things cost a lot to get, a regulated one that fits. But if you're in a developing country, for instance, and don't necessarily have $600 to spend, but there's a 3D printer, you say, well, what about the 3D printer? Well, a lot of 3D printers are showing up really interesting places these days. You can go and say, oh, I need one of these. You go to Thingiverse, you click on it, you order some parts from AliExpress. And it might take 6 to 10 weeks to get there from AliExpress, but you get your various components and you can build your own. And there's a lot of really interesting things that are becoming available with really amazing tutorials to where people can do it themselves, whereas in the past, it required much more effort. And so the same goes with, a part counter on the edge. There's a variety of different ways that your specific application could work. You could have bypass their network completely and just phone home to your own database, just post updates to your own database. And you can perform the OE calculation and demo that to the plan owner and say, hey, this is something that, I could do for you. We could permanently install this if you supply the funding.
Right.
But and show, hey, this really is valuable. So it really does come back down to where is it valuable to add this, and is it possible to do on a low cost? Right now, there's a lot of sensors for things like temperature and humidity and push buttons. But based on doing a little bit of research, there are some wireless photo eyes, but we don't know where they're going. Are they going to a gateway? Okay, you have to purchase Banner's gateway versus, a consumer gateway that, anyone can set up. Amazon and Google spend a lot of money making these Z-Wave products really, really easy to set up. And these consumer grade products don't require an engineer to set up and link to the cloud. Whereas, a Banner might require that, or a Honeywell may lock you into a contract or something. And that's not what most people want. They want something that'll work for 3 months. They can kind of do a consulting kind of role and say, hey, we can get OEE calculations now because we've got part counters, and move on.
Exactly. And if it goes bad, you just replace it with another one.
Mm-hmm.
Either repair or throw away the original, depending on what your application is. Yeah.
So it's kind of hard because it's like drinking from a fire hose. You've got the different standards. You've got to know what sensors to pick, which companies are more open than others. Some are going to lock you into contracts. Some are completely open. Some are free. And just kind of staying abreast of all the new things coming out. It is kind of challenging, but it's also really exciting to kind of see the applications these can be applied to.
Yeah, and you can do so much with these microprocessors now, and gather whatever you need to gather, and then access it remotely, and it's a few dollars, which it didn't used to be that way. Very cool. Well, it looks like it's mostly just been the two of us here. Somebody stopped in briefly, and then I know Carlos Colon. I'm going to give him a shout out. he does a lot of the home automation stuff. I think kind of like you do. You're working with some of this stuff at home, and he's actually been wiring switches and different things in. You showed me, is this the one that you did that was the infrared?
Yep. So right now I have with me, this is a fun little product. I did want to show this off a little bit. This is not related to the part counter, but it could be. This is just a little machine vision camera. It's called OpenCV. This one's small. I've got it attached to some Velcro because I like to stick it different places. And it's got a little lithium ion battery that powers it for a few hours. And this one's doing temperature detection on the edge. It does face detection. So it locates a warm area on my face. I can move it around. I'm holding one in my hand right now. Wow. And it just follows and records a value, and it stores, I could send this value all sorts of different places. There's a little Wi-Fi radio you can attach to this and, access a database and put the values in. All sorts of really super cool applications for this. And we'll include a link to the YouTube video of, just an edge-based temperature detection for monitoring people who are too hot to come in. So it was kind of a fun COVID-19 temperature detect project. You can't necessarily tell someone they can't come into your home because their temperature's too high, but well, it's your home, so you can tell them anything you want. But it's just a fun project to kind of do temperature detection. And I'm not an electrical engineer, but I was able to put together something kind of like, I'm not a computer vision specialist, and I was able to kind of put together some of these different example projects. This is using something called MicroPython.
Yeah, and I do machine vision work with, standard equipment, and that stuff most of the time, like a Cognex camera, you're talking probably on the low end $2,500, and on the high end more like $5,000. And it looks like this thing is far, far less expensive.
Yeah,
some pretty high tech stuff.
Absolutely. So this will do face detection, all sorts of really cool things, and the code is all on GitHub. You don't have to come up with it yourself. Camera's $80. FLIR Lepton, well, that's the adapter. That's not the actual camera, but FLIR Leptons are, what are they going for? $100, $150. So, this product that, I put together, well, it's off now, but the product that I put together like this with infrared capability, $200, $300, nothing more than that. And you can do some really, really interesting things with it.
So if you wanted to, for instance, just draw a line on a white conveyor and count black objects crossing that line, pretty simple thing to do, and then just keep the count local.
Oh, absolutely. So, a lot of these come with example files, but what you said, line counter, and, of course they have the line follow for the robotic applications. People like to stick these on little robots and things.
Yeah, most of the Cognex stuff, you have like edge detection or blob counting or things like that are standard terms. So in this case, when it was following your face, it was actually following a quite complex blob.
Find line segments. This is already included in the library, and this is free software. You don't have to pay for a license or anything. And let's take a look at it. Find line segments. There it is. You just push it to the board and you're good to go.
Wow. I've been to a lot of the vision shows, and on the high end, of course, are these complicated vision systems. On the low end, Matrox, Matrox and I don't know, Edmund Scientific have booths there, and they all sell little gadgets. And I think the last one, I went to one in Boston a few years ago, and they were just now starting to show little Arduino devices and things like that. Of course, the cameras themselves, you can just get a little tiny, it's like a camera on a chip, and do some very basic things with it. And then of course they have all these libraries that you can get with it. And so again, the cost is probably in the coding and the foolproofing, basically making sure that it works 100% of the time.
Exactly. Yeah. The cost has really come down on a lot of this, and depending on the application, if this is for a machine or for a line that you're doing quality control, yes, you can spend more money for a more resilient system that has engineered support for when something goes askew. But if it's just for something very, really basic, you don't want to spend very much money. If it's a proof of concept, don't spend very much money on it, and implement it and see how it goes. And if it overheats in 3 months, okay, that's okay.
We have an application for that right here. Just looking at the bottles from the top and counting them. Right.
Yep,
how many of these little bottles do you have in a package? And if you're missing one, then you need to do something to reject that bottle. Pretty simple, right? If you were to put a Cognex on it, by the time you've wired it in and powered it and bought the camera itself and the lensing and the lighting and all that, you spent certainly $5,000 to $10,000.
Yep, and that's not something most people have it sitting around at home, but most people do have a few dollars. They can start to buy a bunch of devices, microcontrollers, and just start shipping them to their house and playing around with cheap cameras and see what happens. I did want to emphasize a problem that a lot of people have is they order a Raspberry Pi or they order some of these sensors and then they just go to their parts store and die. And I want to really kind of emphasize, a lot of people have a Raspberry Pi. It's an older one. It's laying around. What do you do with this? That if you don't have a project you're working on, if you're not doing something, I kind of want to be an advocate for getting out there and building something with this product. You say, okay, well, I don't know what to build. Well, behind me, I have a board. I'm not sure if I'm still sharing. Let me double check. Make sure I'm still sharing a screen. I am. And the board behind me is kind of this motor demonstration board. And it's shown up in a lot of my various screen shares and things. And people are like, what's even going on here? It's just got 3 little motors mounted on
the screen share so we can see your board better. Because you'll show up still if you kill the screen share.
Oh, let me go ahead and kill that. Well, I'll show you one more thing before I do that.
Okay.
What do you do with the old Raspberry Pi? Well, let's see. Sorry, I had to run away and turn this thing around. I'm using a Raspberry Pi as a little PLC to control these motors. And you say, well, how is that possible? Well, there's a carrier board. You stick your Raspberry Pi on it. There's relays and various switches. And I'm going to do
because what we see is we just see your computer desktop. If you kill that, there we go. Now we can see your background.
There you go. The reason I was kind of keeping the screen share up is I'm using something called Node Red to control it.
Oh, wow.
And so I'm going to pull up Node Red really quick. Well, it was pulled up. Let me pull it up really quick. I'll do screen share again really quick for us. And this Raspberry Pi we can turn on our various motors. You can't see the motors turn on now, but you can see the status change from 0 to 1. And it just turns the pin on or off. And you can hear it in the background, hopefully.
Yeah.
And I've got various motors that I found in the trash. One is from an old drill. One is from an old sewing machine. And they're 12-volt motors. There's a 120-volt motor on here. Starting to get into some real motors with decent power and output. And the main reason I have these motors is I'm doing just basic detection, which motor is running. I'm using a simple microphone. But all the mounts, these little mounts that are on there are 3D printed, you know.
Wow.
All of this is just, you can scrounge around in the trash or your parts drawer, find your old Raspberry Pi that you spent $20 or $30 on a few years ago, and put it to good use doing projects around the house.
I can't really tell what's on that board. That's the motors that I heard running there. The ones.
Yep, those are the motors that you heard running.
Okay.
Let me stop the share now. And I'm just using Node Red with a Raspberry Pi to turn these on, turn them off, record the sounds. I'm using the Raspberry Pi with a microphone to record the sounds and detect which motor's on without attaching to the motor,
Just by the sound.
Just by the sound, because the 3 motors obviously have different sounds when they're turned on.
So what are you using? Is that also a Node-RED or a small microcontroller application to actually process the sound?
Oh, that's just using Python. That's just using, use the microphone, collect a data sample or a data file, store the file, and then perform some analysis on the edge, say, which motor's running, and then report back home which motors are running. It could be a combination of all 3 motors running. Those are all going to create different sounds. And the microphones that we're using for this web conference, they acquire data very quickly. That's a very rapid data acquisition, thousands of samples per second to capture our voices. That can be used with a microphone to establish which machine is turned on or off.
And how long does it take to do to process everything and report to you which motor's running? Less than a second?
Oh, I'd say 2 or 3 seconds. I haven't optimized the program to run super fast. It's more of just a proof of concept at this moment. I'll have to demo that on a different webinar, of course.
That is super cool. Yeah.
But these sensors, these low cost boards can be put to good use, and that's what I kind of want to encourage or say, hey, the technology's out there. You can start to put some of the code that meets the standards on these boards, the do-it-yourself boards that connect to the hubs that are standardized essentially at this point.
You mentioned the people who buy those and put them in a box and they sit there. That's me. I've got 1 or 2 Raspberry Pis and 5 or 6 Arduino boards waiting for somebody to have the time to sit down and do it. Usually I have industrial projects in front of me, or I'm working on writing books or whatever. And so sometimes it's fun to just go play. And
exactly. Yeah. I was one of those people too. I purchased this Arduino many years ago. It was 2011. They started getting real popular. 2012. I purchased it, said, oh, I'm going to get around to some of these projects. I did the Blinky project where you make the LED blink.
Exactly.
And then it went in the drawer for 5 years. Didn't touch it. It's just like, oh, one of these days I'll get to that project. It didn't happen until I got an interesting project where it said, hey, can you tell which motor's running, which motor's not running,
Perfect.
Based on, using a Raspberry Pi. Raspberry Pi and Arduino are 2 different things. One's a computer that's running Linux. The other one is just a microcontroller using C++ to kind of collect some information. Yeah. Raspberry Pi is probably overkill for some of this, but
that's kind of where we were getting to the discussion. I think for the remote devices, something like an Arduino board would be fine just to keep account. But the gateway or whatever that controls all these things may very well be a computer and store some data and put it on a SIM card or whatever, or a SD-RAM card or whatever. I'm going to go ahead, and I think we're about at the end of our time. Man, I learned a lot, like I did last week when you came up here. We got to talk about a lot of different things, and you showed me some of the infrared, detection stuff. I was astonished by that because I don't mess with it, like I said. Let me see here. Go ahead and flip back to this. And this is kind of where I left off. I just had some other pictures and things here, but there's nothing critical. I think we talked about most of these. This is kind of an encapsulation of some of the ideas we had. I did want to bring up handshaking connections, some kind of a back and forth to make sure that you're still connected to the device. I've noticed here, for instance, I have a, who's the manufacturer? I have a gateway here that the only thing I can tell is that the entire gateway is running it rather than individually telling whether the thing's connected or running. So I would have to write some kind of a handshake back and forth to the individual devices within the gateway to make sure that's running. And then I think we hit most of this too, home automation and remote monitoring cellular modems. So this was all the stuff that that I had put on my list, and you hit them anyway in your presentation. So that's awesome. So the next webinar, and it looks like somebody else is joining up here at the last second, but the next webinar, I don't even know what day it's going to be because I'm going to Oklahoma, and it was supposed to be on that Friday, and I'll be driving back that day. I can't do it Thursday because I'm not there. Lavelle, it looked like you probably are 1 hour late. I'm sorry you missed it, but we covered a lot of really good stuff, and I'll definitely put it on YouTube. My YouTube channel is this right up here, Automatic-High, and I'm also going to put a link to Phil's YouTube because Phil did his infrared camera application. He put a little video of that running on his YouTube channel, so I'll definitely put that up there. So next webinar, August, I don't know what. I know that it lands on the Friday. I'm driving back from Oklahoma, and I don't know if I'm going to have a guest, but my best bet is probably doing it on a Saturday or something. So, but sorry we missed you, Lavelle. I think time zone wise, yeah, that's a 12 o'clock my time, and I think Phil's on Eastern time right now too. So, but that is the end of this webinar, and I appreciate you guys showing up, and we'll talk to you later, Phil. I'm sure you and I will be in contact.
Yeah, it was a pleasure.
Yeah, well, thank you very much.